Thank you for watching this Hexagon Geospatial e-training module, Project Creation using ISAT. The Image Station Automatic Triangulation, or ISAT software, performs an automated aerial triangulation from digital aerial images to be used with the creation of such things as topographic maps. The ISAT software also allows you to enter the point transfer and measurement environment manually. In this module, you'll learn how to set up a new project using ISAT, as well as how to import the necessary components into the project for the project's creation. First, we'll create the initial project. Once you have ISAT running, go to File, New Project. Type in the name of your new project. For now, use training_ISAT. The location field will automatically fill in your project name. However, you'll still need to either type in or find the location of your new project. When done, click Next. By default, the aerial photography and ASCII options will be chosen. For now, leave these as is and click Next. Now define a coordinate system to use with the project. Always choose a coordinate system best for your image area and project. We'll do this now for the imagery in our example. Click the button next to the coordinate system field. Under the General tab, select Projection for the coordinate system type. Navigate to the Storage Space tab. 1 meter will automatically be filled in for the horizontal and vertical storage units. For this project, leave these as 1 meter. Now navigate to the Projection Space tab. Here select Gauss-Krüger 3 degrees for your projection algorithm. Click the Projection Parameters option and change Zone to 3. Click OK. Now you will need to determine which geodetic field to use. Go to the Geographic Space tab. For the geodetic datum, choose DHDN, or the option that best fits your data. Then choose DHHN92 for the vertical datum field. Click OK to save and close the dialog. Click Next to move to the project parameter settings. Here you will modify the parameter settings for the ISAT to create the most accurate aerial triangulation. Now enter the settings for your project. For this project, enter 3 in the standard deviation of measurement, 1100 in the flying height field, and 400 in the ground elevation field. The flying height point must be a greater number than the ground elevation point. Click Next and move to the project user setting. For now, you will change just the max RMS and max residual values. Enter 0.07 in the X, Y, and Z fields for max RMS. Then enter 0.1 for X, Y, and Z for the max residual. Both of these fields are always in meters. Click Next to go to the last group of settings for creating the initial project. The last section, Default User Settings, creates the point patterns for the project. Here you can choose a 3 or 5 point pattern, or you can create your own set of points with the fields at the top of the dialog. Although this section is not required when creating a project, you'll define one of the predetermined point patterns for this project. Use the 5-point button as the user point patterns. Click Finish. Your new initial project has been created. Now you'll learn how to add image information about the camera you used for this model into your project. This information will be based on the camera, not just the images. First, go to Edit, Camera Wizard. Now enter the type of camera that was used in the camera name field. For this project, use RMKDX. Select Digital for your camera type, then click Next. When a film-based camera is used with ISAT, an additional tab will appear to enter the fiducial coordinates. Next, we'll add information about the camera. Under Camera Data, add the following information. Enter 92 for the focal length. Next to Principal Point of Auto Culmination, enter 0.003 in the X field and 0.001 in the Y field. Enter 12,096 for number of lines, 11,200 for samples per line, and 7.2 for both line width and sample width. Click Next. If your camera calibration report provides lens distortion values, check Enable Lens Distortion Correction and set the necessary values for distortion value format, distortion value, and distortion mode provided in the report. For this project, leave the distortion options as the default. Click Finish then click Yes. Next, enter the Exterior Orientation Parameters, or EO parameters, into your project. The file containing the EO information must be in ASCII format. Navigate to Translators, Import, EO GPS INS, PO SEO. Find the file which contains the EO parameters. The parameters in the EO file can be one of three types as seen in the Exterior Orientation Type menu. For this project, select GPS INS. This will activate the option to import the timestamp associated with the GPS INS data. We'll come back to this in a moment. You can also look at a preview of the input file to ensure the content and format is correct and help you fill out the settings field. Click the View button to review the format of the input file. The imported file needs to be formatted so each row represents a single image, and each column contains only one type of information. Use the EO GPS INS PO SEO settings field to modify the fields based on your data format. If your file does not contain the listed type of information, check the box next to that field, then fill out the default value. The default value will apply to all the images in the file. Fill in the following information: Strip ID 1, Photo ID 2, Image ID 10, Timestamp 3, X 4, Y 5, Z 6. Change omega to 7, phi to 8, and kappa to 9. Change the standard deviation X, Y, and Z fields to 1. Click OK. The EO will now be imported and the photo parameters set. Next, you'll import the file containing the ground control points, or GCPs, with their associated locations. Go to Translators, Import, Control Points. Select the file with the ground control points. Use the View button to review the file's content and format to make sure that this is the correct file. Fill in the control point information by providing the column number that contains the correct information for each field. If the information is not provided, use a 0 in that field. If the standard deviation values are not given, use the default standard deviation values for SX, SY, and SZ. For this file, set SX, SY, and SZ to 0.03, 0.03, and 0.05 respectively. Click OK and the points are imported. You'll now need to set the path to the images. Go to Edit, Image Paths. Make sure Find and Replace Photo Image Paths is checked. This will ensure that the path you choose here replaces the file's current path. In the Find What field, select the current path assigned to the images. In this case, it's a backslash. Use the Replace With browser to locate the correct images, then click OK. Click Apply, then Yes, then close the dialog. Finally, you'll create the model based on the information provided in the previous steps. Go to Edit, Modify Strip. If necessary, you can use this dialog to make changes to the model information. Select Create Models. Select all the photos from the available photo list. Click Apply, and Yes. Finally, close the dialog box. View the results by going to Tools, Footprint Viewer. Once the model is created, it's a good idea to save 2 copies of the project, one for automatic use and the other for manual. Do this before continuing with your project. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, visit hexagongeospatial.com/e-training.